Hi, my name is Matt Maxwell, and I'm a product manager for Tektronix Spectrum Analyzers. And this is a quick how-to video for testing ZigBee device first power on. So even if you're buying a pre-certified ZigBee radio RF module, it's still useful to have a spectrum analyzer to make sure that it's turning on correctly and to make sure there's not something seriously broken about the setup once you have it for integration of the module into a ZigBee device. So to do this testing, what I'll have here today is a Tektronix RSA607A. This is a USB controlled spectrum analyzer that's being driven from the PC here running SignalView PC software. So let's get started. So what I'm showing you today is a RSA600 real-time spectrum analyzer. Now this is a USB analyzer and you're looking at the SignalView PC software screen. And I'm performing just basic spectrum analysis measurements. I've got basic 4 controls across the bottom here for frequency. The center frequency, which I happen to know is the same as the center frequency as my ZigBee device, is 2.445 gigahertz. The reference level controls the maximum amplitude level set on the top of the screen. And then the span right now is set for a gigahertz. So let's say, for example, I wasn't sure if I was using a 900 megahertz ZigBee device or a 2.4 gigahertz ZigBee device. Maybe I have to sweep a wider frequency range to determine which frequency the signal is being transmitted in. And then any spectrum analyzer needs to have a resolution bandwidth setting, which can be changed depending on what types of tests I'm performing. So I can see right off that I've got the ZigBee signal here. Maybe now I want to reduce the span to 10 megahertz, and I can see there's some sort of pulsing signal. It's turning on and off. So I can clean that up a little bit by using a trigger. Most spectrum analyzers have some kind of level trigger, and the RSA600 is certainly the same in that respect. So I turn the trigger on, and the default trigger level, actually it's not the default, I've already set this to minus 14 dBm. This is low enough of a trigger threshold level to cause me to trigger reliably off every single transmitted burst for this ZigBee device. So it's good when you're first turning on a ZigBee device, you want to make sure that it powers on correctly and that you have the spectrum in the area where you expect to see the spectrum. And then maybe the next step might be to perform some basic RF measurements, like looking at the channel power, for example, to make sure that you're not transmitting power outside of the range that you think you are, and also at the right power limits. So here's a channel power display, which I can pull up and run concurrently. And here I see the main channel power, if you can see over here on the left-hand side, is minus 7.5 dBm. And if I want to look at the settings for these, I did already have this set up. I set the center frequency and the RBW used. Now different wireless standards may call for a different measurement bandwidth or resolution bandwidth to be set depending on the test. I look at the measurement parameters. Here I could average the trace if I'd like. So for this particular ZigBee signal, I'm transmitting the same sequence of ones and zeros in every single burst, which I'll get to that in another video to show you that. But the point of that is that averaging doesn't have an effect here, but it would in other signals. There's some sort of filter that needs to be applied for a channel power measurement. This is how most wireless standards are written, and so I've got a filter set up here. And I've told that I want one channel, basically, or one number of adjacent channel pairs with a 2 megahertz channel bandwidth, and the channels are 2 apart. So basically what I see, maybe you can't see it here, there's faint gray vertical lines here indicating the 2 megahertz channel where I'm measuring the power. So I could change that to something else if I wanted to. And you can see these gray bars getting larger. So if it's really a 1 megahertz channel that you want to look for, there's a 1 megahertz channel where now you look at the main signal. Now the number got smaller here. Remember, a channel power measurement is the integrated power across an entire bandwidth. So in this case, a 1 megahertz bandwidth is containing minus 9.1 dBm, and then you have adjacent channels here as well. So that's a couple basic tests that you might want to perform, maybe extending now on spectrum analysis It's helpful to have maybe some more controls with spectrum analysis. I may want to add some additional traces. So there's a max hold trace here. And then also enable the third trace in green, which is an average trace. Again, for this particular signal, it doesn't look that much different until I go to a wider span and I turn the trigger off, because again, the repetitive nature of the signal means the average trace in green here would look the same in the area where I'm transmitting. I've changed this to be a wider span so I can see the effect of the max hold, the peak detection, and the average traces, which are the three traces turned on here. And I can control those under the traces menu for the SignalView PC spectrum analyzer. So each trace 1, has the peak detector. This is the trace in yellow, and it's a normal function. Trace 2 is the max hold trace with the plus peak detection function as max hold. And trace 3 is an average trace with an average detector, average function, and I can turn up the number of averages if I want. And the last thing to show are basic marker measurements that I have in a spectrum analyzer. So I can add a marker and I can look at the peak power. Now at the moment the marker is assigned to trace 1, so I have to, if I go to peak, it's not at the very top level until I change that to be assigned to trace number 2. So now it goes to the peak. And I see a minus 16.57 dBm level. I have additional markers that I can add here, but that's just basic spectrum analyzer functionality, spectrum analyzer features like channel power. There's others like occupied bandwidth to see the bandwidth that your signal is occupying, like the name says. And all of these are good tests to have for the first time you power on a radio, any radio, including a ZigBee radio, to make sure that it's working and behaving the way that you expect it to. So hopefully that gives you a little better understanding of what types of measurements you might want to do the first time you're turning on a ZigBee device, integrating a module into a ZigBee device. So hopefully that's helpful for you, and I thank you for your time.